Hi everyone, I'm Tasfaun Alamu. On this video, I will present for you how to analyze PCA and clustering analysis using R. So the first thing you will do is to set your working directory. So for this analysis, we need genotype by trait table, the genotype by trait mean table from the single location over location analysis output. So to set the working directory first, here you can go here as file. In my case, it is from my desktop. Then data, example for our training, and then I will go with the setting icon here, and then set as working directory. So now directly I go to the working directory. So the next part is read the data file. So to read the data file, I can make it like this. In the quotation, I will try to touch the tab, so he will list for me the list of the files. So this one is a file I'm interested to use. So but since it is an Excel file, I should give him the read Excel function, which sheet I want to read. So in this case, the first sheet is what I'm interested to read, and the name of the sheet is blue mean individual location. So I will read this one, and this is the data. These are genotypes. These are different traits. So, and also I will change this as a data frame for some manipulation, especially for row naming. Then the next one is to do the PCA analysis. So PCA analysis can be done in R using the base function precomp, or you can analyze using the factor minor package, and also use factor extra package in order to visualize it. So I will load these two packages, factor minor and factor extra. If you don't have this package, please install it. The next part is after I bring the data, I should name my data the row name using my genotype names. So I use the row name, mean data, and the name using the genotype name. So I will name based on the genotype. Since I already named the row name of my data, I should remove the genotype column. This is remove the genotype column. Okay. The next step is, since as you see the data have different units, like different units, so it means if you have different units, it is the best way to make scale or standardized or scale it. So this standardization can be done using the scale function. So in this scale function, you can use scale through center through, so we will standardize it. And then using this standardized or scale function, scaled data, we can analyze the PCA. So the PCA analysis will be done using this function, simple PCA, gives the name of the data. Yeah, this is the output. So the first output, at a glance, it shows you how the relationship of the traits. This is, for example, trait 1, trait 6 highly correlated, trait 5 and trait 8 negatively correlated, trait 1 and trait 5 is it have a 90-degree, so it is independent or zero correlation. So this shows the relationship between the traits, and this will show you how the distribution of the genotypes using the two PCS or dimensions. So in this case, the two dimension explained about 59% of the total variation. So PCA1 explains 36%, PCA2 22%. So this is how you plot it. So the other one is to this summary of the PCA output. Here we have saved. You will use the PCA output. This will give you the information, some summaries, especially here, how the proportion of each dimension or each PCA explained in the first PCA. The eigenvalue is 2.9, and then it explained about 36%, and the second one explained 22%. Its cumulative will be the first and the second 59%. So this you can get from the summary. So the next one is this is the individual score for it, so it's okay, and this is the individual score for the variables. As you say, for example, trait 1 is individual score from dimension 1 have 0.89, and its total contribution is about 26%. Yeah, so if you go trait 1, for example, in this plot, trait 1 is, as you see, 0.8 something around here in the x-axis we have, and then in the y-axis you will have in the 0.2, so that is really around here and then around here, so 0.2 something. So this is the score of each of the variable and the individuals. Okay, the next one is you can explore also inside each PCA output. The eigenvalue is the one you will see, the eigenvalue and total variance explained by each PCA or by each eigenvalues. The next one is the contribution of each trait in each PCA value. For example, trait 1 have the highest and trait 5 have the highest contribution. In the second dimension, in the second PCA, trait 5 have the highest contribution, followed by trait 7. So like that, you can see how they contribute in each PCA. Okay, so the other one is the most important part. Since this is data, as you see, these results show you the graph is independent for each trait and the individuals, but we need to have the combined the trait and the individual together in order to visualize when we superimpose the trait over the individual. So here we have, in fact, extra package, we have this function PCA biplot. So we will give the output of the PCA, and then we will give the individual color, red, blue. Here, for example, I can put blue. If it is red, it's not interesting. And the other color of interest, blue. And then label none means I don't want any label, so I can run it. If I run it, do you see there is plots of the genotypes and the trait, but we don't have any label information, so we need to have that label information. So to have the label information here, label is none, so now I will remove the label is none in the second component, line 28. So if you run it again, you will see this output. So this output show you, this is the output show you that this is the biplot, the trait, and the individual distribution. So this superimpose the two components, the trait and the individual, together in the biplot. So this shows that trait 5 and trait 8 is negatively correlated. Trait 1 and trait 6 are highly correlated between them, and trait 5 is independent. So this observation in the left side have low performance for the trait, the target trait. So likewise, we can explain how this biplot is. Okay, so with this we finish the PCA component part. The next part is clustering analysis. So the clustering analysis we use it is different from that of the PCA. In the cluster analysis, first we should estimate the distance between individuals based on these multiple traits, and then after the distance we make it hierarchical clustering, and then after this hierarchical clustering we plot that hierarchical clustering output. So here, for example, we have the mean data we'll provide, and then the method of distance is Euclidean here, the default, but you can do any distance you like. So we run this one. We have the genetic distance between individuals is estimated here. If you see it here, that there is a different the distance matrix as you see it. The next one is using this distance matrix and complete linkage, we can make it hierarchical clustering. But we can also change an average or any other method. If you have different method of interest you can use, you can go here, for example, single, here as you say, single complete average. Average means UPGMA, median, centroid, word, or anything. You can select which one of interest depending on your data. So in this case we'll continue with complete. So I will put the H classed for clustering, hierarchical clustering analysis. We, as an input, we use the genetic distance, the distance between genotypes estimated in this line 34, And then after that I will plot HC output like this. So as you see here, we show the dendrogram using the complete linkage method, and he shows us this is the dendrogram of the output. But as you see, this output, if you want some coloring or different type of graph, we can use another function. Here, for example, there is a library called app library. So in this library, we have some functions that can help us to plot a circular type of dendrogram. So in this case, we can change the dendrogram using with the hierarchical clustering output as a dendrogram using this function as dendrogram object. So then using the library app, we can plot this HSD, this hierarchical clustering thing into plot. So as you see it, this is the output of the dendrogram. Okay, this is the output. So you can see how the circular dendrogram is look like. Okay, then the next part is, if you want to make it interesting to have colored this dendrogram or this one, so you can give the colors. So this is the list of the color you are interested to give. In this case, if you are interested, for example, 6 clusters, we will have provide the list of 6 colors. We save as a colors. And the next one is we will use cut tree function in order to cut the hierarchical clustering into 6 parts. So we will use to cut into 6 parts here. And then we with this information, the color, and the type will be fan, means the circular one, and then we will use here HCD as an input, so we can plot it. Yeah. So as you see it here, this is the graph. So we have different color. But if you are interested to increase the size of the text, here you can manipulate here, like this is 5. If you make it 5, for example, yeah, it's a little bit big. So now you can put this one, and then if you zoom it, yeah, this is the output of our graph, like this is green, blue, red, yellow, and black colors. So this is 6 type of color, and some is pink. So this is the graph, the total, the circular graph. That's interesting for us to put in our article or in our report. Okay, the next package you can use also to plot a good colored dendrogram is using a dendro extend package. This dendro extend package library, we can load this one. As I said, we can save this hierarchical clustering output as a dendrogram object using this one function, and then this dendrogram object we can put this dendrogram object, and then the next part is we can save the dendrogram object here, for example, the dendrogram object here. Then you put this dendrogram object, and we set the label. For example, this is the label of the genotype label, and the label can be, the size is 0.4, 0.5, you can increase it. So here we set it, dendro1, and after this dendro1 will be used as an input for this one, but the cutting point is 20. that the cutting point is 20, and then if you run here and finally plot this one. So as you see it, since we give him as a cutting point say 20, when you see it's the graph here, this is a graph. So as you see it, if we make it 20, it means he will cut here, cut here, cut here, cut here, cut here. So we have almost 1, 2, 3, 4, and 5 groups. If you put, for example, 25, it means we will have 1, 2, 3 groups. Like that, we can arrange the cutting point depending on our result or interest. So here, since the cutting point is 20, so he put for me 5 cluster with different color. So he puts the color for me. So this is how you plot the dendrogram. So now you can export this dendrogram to the your file, or you can save in your computer. This can be done simply. For example, this is it, and then you can make save images. Dendrogram color 1, okay, dot png, or TIFF can make it png. So save. So like that, you can save your output. All the outputs can be saved like this. So like using this, you can produce your dendrograms and your PCA plots. So now we have seen how to analyze PCA and clustering analysis. So I'm finished my presentation. Thank you very much for your attention. Please, if you are not subscribed, please subscribe and share to your friends. When you subscribe, when I upload a new video, you will receive as soon as I upload, so it is helpful for you. So thank you very much. See you by next video. Thank you.